In this lesson, we want to review the coordinate plane. So in this section of our course, we will review graphing equations with two variables involved, and we're also going to discuss functions. So before we can kind of get into those topics, we need to make sure that everyone understands the basics. So today we're just going to start out the section by reviewing the coordinate plane and again how to plot an ordered pair. So before we jump in and start talking about the coordinate plane, let's first review the concept of an ordered pair. So pretty much up to this point in our course, we have exclusively worked with equations that have only one variable involved. In this new section, we're going to look at a lot of equations with two variables involved, normally x and y. Okay, so suppose we saw the following equation. Suppose we had something like 2x and then plus 9y is equal to 20. Okay, so this type of equation is known as a linear equation in two variables. Most of you have seen this if you've taken an Algebra 1 or an intermediate algebra course. You've seen this type of equation, and you know when you graph this type of equation, you get a line, right? Henceforth, the term linear equation. Okay, so when we work with these types of equations, we find that there's an infinite number of solutions. Okay, so there's an infinite number of kind of x and y combinations that satisfy the equation, or again, you could say make the equation true. So in order to get kind of a visual representation of the solution set, it's normal for us to graph this type of equation on our coordinate plane to kind of see what's going on. So we're going to graph linear equations in a few lessons, but most of you already know this is a pretty easy process. For now, we just need to understand how we can write solutions for our equation using ordered pairs. Okay, so basically an ordered pair consists of two components which are written inside of parentheses and separated by a comma. So when we write an ordered pair, the order of the components are important. Now, normally in our studies with algebra, you're going to see them written like this. You're going to see, again, inside of parentheses, your x value, comma, your y value. So it's easy to remember because it's in alphabetical order. X is before y in the alphabet, and x is before y in the ordered pair. Okay, so you can just remember it like that. So as an example, one solution for this linear equation in two variables would be that x equals 10. So I'm just going to write this over here. I'm going to say x equals 10. And y is equal to 0. So you've got to have two values there, one for x and one for y. We're going to plug both of those in and show that this is a solution. So if I plug in a 10 here and I plug a 0 in there, let me kind of scooch this over and out of our way, you'd see that 2 times 10 is 20, plus 9 times 0 is 0. So you can basically just say this is 20 is equal to 20. So we know that this guy is correct. So to write this solution as an ordered pair, again, I just follow this format. All I'm going to do is put my x value first. So in this case, the x value is 10. Then comma, my y value comes second. So that's going to be a 0 there. So you've got 10 comma 0, right? Again, enclosed inside of parentheses. Your x value is first. Your y value is second. Okay, so that's how you write your ordered pair. As another example, we could show another solution. So let's say that x is equal to 3 and y is equal to 14/9. Now don't worry about where I'm getting these solutions from. We'll talk about these types of equations in a few lessons. Right now we're just getting the basics down. We're learning how to write some ordered pairs. So again, if you wanted to check this, you could plug in a 3 for x. You could plug in a 3 for x, and you could plug in a 14/9 for y. Let me erase this so we can just check this real quick. 2 times 3 is 6 plus 9 times 14/9. We know that the 9s would cancel. So we'll go ahead and just cancel this with this. I'm left with a 14. And essentially you have 6 plus 14, which is 20. So you would have that 20 is equal to 20. So this guy is going to check out as well. Okay, so let me erase this. We don't need this information anymore. So how would I write x equals 3, y equals 14/9 as an ordered pair? Again, just follow this format. The x value comes first, so I'm going to put a 3. Then comma, the y value is second, so it's 14/9. Again, they're separated by a comma, and they're inside of a set of parentheses. All right, so now that we understand what an ordered pair is and kind of how to write an ordered pair, let's move on and talk about the coordinate plane, and then we'll get into how we can plot an ordered pair on our coordinate plane. So we've all seen this basic number line. We pretty much haven't done much in the way of graphing up to this point in the course. we pretty much just use our number line for working with inequalities, right? So if we had something simple like, let's say 2x minus 3 equals 7, we could actually graph our solution for something simple like this using a horizontal number line. If we just add 3 to both sides of the equation, we would find that 2x is equal to 10. We divide both sides by 2, and we would find that x is equal to 5, right? So this is our solution. Very easy to get. Everyone at this point should understand that. So graphically, on a horizontal number line, I can just say that at 5, I can just put in a filled-in circle or filled-in dot, however you want to think about that. That represents my solution, right? This value here of 5. But when we move in and start talking about an equation with 2 variables, we're now going to need 2 number lines. So we're going to need to look at something like this, right? So this is our coordinate plane. You have 2 number lines involved. And when I say coordinate plane, I don't want you to get confused because there's a lot of different names floating around for this thing. You might hear the Cartesian coordinate plane. Okay, that's named after its founder. You might hear the rectangular coordinate plane. There's a lot of different names floating around for this. I'm just going to refer to this as the coordinate plane, okay, just to make it real simple. Now, what you'll notice here is that you have these 2 intersecting number lines. So we've got our horizontal number line that we're used to. Okay, this one's going kind of left and right. And then we have this new addition, this vertical number line. Okay, we're not used to that. But what you'll notice is that they intersect at the point where each number line is 0. So this spot right here is the point of intersection. It has a special name. It's known as the origin. Now, let me write this off to the side because I'm going to end up erasing this. So this is the origin. And this occurs at the point 0, 0. The x value is 0, the y value is 0. Okay, so that's why I wrote 0, 0 as an ordered pair. So this is the origin, x is 0, y 0. All right, so let's talk a little bit more about this coordinate plane. So the horizontal number line, the number line that we're used to working with up to this point, is known as the x-axis. Okay, you see this little x here? I can put x-axis for the sake of completeness. And basically this number line represents our x values, okay? So what we can see here, just like we're used to, numbers increase as we move to the right, and they decrease as we move to the left. So if a number on this x-axis is to the right of another, then it's a bigger number. If a number on the x-axis is to the left of another, then it's a smaller number, okay? So anything to the right of this kind of origin or to the right of 0 is going to be a positive number. Okay, we need to note that. So anything in this direction is positive. Then anything to the left of the origin on the x-axis or to the left of 0 is going to be negative. Okay, so it's very important you understand that for the purposes of what we're going to do in a minute when we start talking about quadrants. So to the right of the origin or to the right of 0 on the x-axis is positive. To the left of 0 or to the left of the origin on the x-axis is going to be negative. Okay. Now we also have this vertical number line. Basically, we just took this number line and rotated it, okay? So this is known as the y-axis, and it represents y values. So I can just say this is the y-axis. And essentially what we see is that numbers increase as we move up, okay? So they increase as we go up. So if a number is above another number, then it's a bigger number. They decrease as they go down, okay? So if a number is below another number, then it's going to be a smaller number, okay? Now, anything above 0 or anything above your origin is going to be positive. So this is going to be your positive values here, kind of going up. And then anything below the origin or anything below 0 is going to be negative. So now let's move in and talk about the quadrants. Okay, so we can split our coordinate plane, and I'm just going to erase this, up into 4 quadrants. And I'm going to erase this too. We don't need this anymore. So essentially what I have is a movement that goes counterclockwise, starting with the top right. So this guy right here would be quadrant 1. Okay, that's the top right. We move counterclockwise, so we're going this way. This guy right here will be quadrant 2. We're moving this way. This guy right here will be quadrant 3. We're moving this way. This guy right here will be quadrant 4. Okay, when you first start working with your coordinate plane, you're going to be asked to plot ordered pairs and then to also determine what quadrant it's located in. So the main thing is to understand the kind of signs of your numbers involved. So when we look at quadrant 1, we can see that x values are positive and y values are positive. How do we know that? Well, if we look at our x-axis, we're to the right of 0. If we look at our y-axis, we're above 0. Okay, so any x value here would be positive, any y value would be positive as well. When we move into quadrant 2, when we look at our x-axis, we're to the left of 0 now. So our x values are going to be negative. Our y values are going to be positive, though, because we're still above 0 on the y-axis. So we're good to go there. Then for quadrant 3, we're still to the left of 0 on the x-axis. So that means x values would be negative. We're below 0 on the y-axis. So that means y values will also be negative. Then when we get into quadrant 4, we can see that our x values are going to be positive, right? Because we're to the right of 0 on the x-axis. And then our y values are going to be negative because we're below 0 on the y-axis. Okay, so just remember this. You might want to write that down in your notes. For quadrant 1, it's positive, positive, right? X value is positive, y value is positive. For quadrant 2, it's going to be negative, positive. Okay, so you have x values that are negative, y values that are positive. For quadrant 3, we have negative, negative. So x values are negative, y values are negative. And then for quadrant 4, kind of to wrap this up, we see that our x values are positive and our y values are negative. Okay, so something you might want to write down because something you just want to remember for kind of reference sake. If you don't want to write it down, just remember that the top right is the first quadrant and then it goes counterclockwise. So you can just derive this. You can say, okay, this is 2, this is 3, this is 4. And then you can just look and see, okay, are my values positive or are my values negative for each quadrant? Now, it's very important to note this because this comes up as kind of a trap question. If you were located on the x-axis or the y-axis, right? So let's say I got a point that was something like 6, 0. So that's going to be right here. We'll talk about plotting ordered pairs in a minute, but this is 6, 0. So this is on the x-axis. This is not located in any quadrant. Okay, so if you get asked that question, it's not located in any of them. A lot of students will make the mistake and say, okay, well, it's in quadrant 1. Right? Because they'll say, okay, well, the ordered pair 6, 0. They'll incorrectly say, well, 6 is positive. That's true. But they'll incorrectly say, well, 0 is positive. 0 is not a positive number. 0 is not positive. It's not negative. It's neither. Okay? So don't make the mistake of trying to match that up and say, well, in quadrant 1, things are both positive, and then 6, 0, each thing is positive. That's incorrect, right? Because 0 is not a positive number. All right, so now let's move on and look at a little exercise that's going to help us understand how to plot an ordered pair. Most of you know how to do this, and you understand the process is very, very simple. So an ordered pair, when we work with them, it's usually referred to as a point. Okay, so we could say we're going to plot the point. That's just meaning we're going to plot an ordered pair. Okay, so we're just finding the meeting point of the x location and the y location. We're going to draw a little closed circle at that point, and then we're sometimes going to write the ordered pair next to it. In some cases, you'll also have like a capital letter associated with it. You might want to write that there, just depending on what they give you. We'll see the capital letters in the exercises that are associated with this lesson. Okay, so what we want to do here again is just plot each ordered pair, and then we're going to determine its quadrant, okay? So we're going to start with -5, 5. So this ordered pair here. So I'm going to come down to my coordinate plane. So -5, 5. And then for my quadrant, I'm just going to put Q. And I'm going to put a question mark for right now. We'll figure that out in a minute. So how do we plot this, or how do we graph this ordered pair? Well, essentially, I've got to think about the fact that, again, let me kind of slide this down. This guy right here is an x value, okay? This is an x value. This guy right here is my y value. Think about how this is constructed. The x values are on the horizontal axis or the horizontal number line. The y values are on the vertical axis or the vertical number line. So the x value tells me how much I'm moving horizontally, right, left and right. The y value tells me how much I'm moving vertically, up and down. If you have a negative, you're going to the left. If you have a positive, you're going to the right in terms of the x values. With the y values, a positive is going to go up and a negative is going to go down, okay? And it's a lot of information at first, but after you do a few of these, it's very intuitive, okay? So if I start at the origin, and I just kind of use my information here to kind of move, my x value is -5. So just go 5 units to the left, or just go to -5 on the x-axis. So that's right here. This is -5. Then my y value is 5. So that tells me vertically I want to move 5 units up. It's a +5. So from -5, I'm just going to go 1, 2, 3, 4, 5 units up. And what you see is that this is basically the meeting point of an x value of -5 and a y value of +5. Okay, if I drew kind of a little line extending this and a little line extending this, you can see that's the meeting point, right? So this is -5, 5. So that's one way you can do it. There's obviously quicker ways. What I basically do when I do this now, and I kind of erase my points, so let me draw that back in. So this is going to be right here. What I do when I do this now is I just go to the X location first, and then I move up or down based on the Y location I'm given, okay? So in this case, I would just go to -5 first. I don't need to start at the origin. And then my Y location is 5, so I just go up 5 units, okay? That's all I need to do. Now, what quadrant does this lie in? Remember, the top right is quadrant 1, and we go counterclockwise. So this is going to be in quadrant 2, right? This would be quadrant 3. This would be quadrant 4, okay? So the quadrant that it's in would be quadrant 2. All right, let's grab the next one. So the next one is 3, -7. So 3, -7. So let me erase this, and I will put 3, -7 there. I'll erase this because we don't know what quadrant it's in yet. So again, you could start at an X value of 3, so that's right here. And then the Y value is -7. So a negative in terms of a vertical number line just tells me I'm going down, right? I need to go down. So I'm going to go down by 7 units. So start at 3 on the X-axis and go down by 7 units. So basically right here, right? You can see the Y value here is going to be -7. So if you extend from here, you see that's the meeting point between those two. So this is going to be 3, -7. And if you wanted to do this differently, you could. You could start out at the Y location. So I could have started out at -7, so right there. And then my X location or my X value is 3. So it just tells me I want to move to the right by 3 units. Again, that'll get me to 3, -7. So that's going to be my location. Now, for the quadrant, this guy is located in quadrant 4. So the quadrant is quadrant 4. All right, so now we want to look at -4, -4. So let me erase this, and I'll put a -4 here and a -4 here. So what we want to do, again, is go 4 units to the left. I want to start out at -4 on my X-axis. This is -4. And then I have a Y value of -4, so that just means I'm going down by 4 units. So I'm going to find basically -4 on the Y-axis. It's the meeting point between the two. So 4 units to the left and 4 units down. That's going to be right there. So this is -4, -4. And this is located in quadrant 3, okay? All right, now we have -2, 8. So -2, 8. Let's erase this and this. So -2, 8. So we would, again, I'll kind of mix this up just because you can do it either way. I'm going to start out by going to 8 on the Y-axis, right? Because I'm going 8 units up. So this is 8. I'll just kind of circle that. Now my X value is -2. So horizontally, I just want to move 2 units to the left. Again, if this is negative, it's telling me to go to the left. So I go up 8 units, and then I go left 2 units. And this is kind of in the way, so let me kind of move this. So again, I would just go 2 units to the left, so 1, 2. So this right here would be -2, 8. So -2, 8. And it's kind of squished in there, so let me erase that, and I'll put it up here. So -2, 8. That's a little better. So let me write that the quadrant here is going to be quadrant 2, okay? And again, you could have done this a different way. You could have started at the origin and moved 2 units to the left and 8 units up. That'll get you there also. Or you could start at -2 and just go 8 units up. Or again, like we did, you could start at 8 and just go 2 units to the left. A lot of different ways to do these. Again, for me, I always just start at the X location. So I would have started at -2. My Y location is 8, so I would just go up 8 units. All right, the last one is 6, 0. And if you remember, we talked about this earlier in the lesson. So let me erase this and put 6, 0. So 6 here and 0 here. So what are we going to see? So again, my X value is 6. So from the origin, I can move 6 units to the right, or I can just go to 6. So that's right here. Now, what am I going to do when I have a Y value of 0? Well, essentially, if I look at just the vertical number line, if I highlight that, where is it 0? It's 0 on the X-axis, right? So on the X-axis where I don't move at all up or down. So I'm just going to stay at that point, right? I'm just going to stay right here. I move horizontally, but I don't move vertically, right? In terms of the origin. I can go 6 units to the right, or again, I could just start at 6 and I don't move at all vertically, okay? So this guy right here is on the X-axis, and when it's on the X-axis or on the Y-axis, you are not in any quadrant. So we can say not in any quadrant, okay? And that's a common trap question on a test to give you a point on an axis. either the y-axis or the x-axis and say what quadrants it's in. It's not in any quadrant.